Today we will just start with some exercises regarding data pre-processing. So before starting some exercise, let me give some overview because yesterday just the time was it's not went. So today let me give some overview. So is the presentation is visible?
Yes, sir.
Okay.
Yes, sir.
So for the data pre-processing, the main techniques will be like data acquisition. Data acquisition is how you are going to acquire the data. Okay, so the data can be any format. Either it can be a CSV format, Excel format, or SQL file format, database files, or like a cloud files, text files, or sometimes it can be a videos, images, audio files, whatever the data may be. So before starting any process in a machine learning or in a data science, so there is a process with the first step. The first step laying this process known as data acquisition. Okay, then we follow through this process from data exploration techniques, data wrangling techniques, and manipulationing, typecasting. Typecasting is nothing but changing the data types, changing from strings to from integers to string, or like from float to string. Typecasting, like from converting array to pandas, array to data frames, or array to tensors. We call this as typecasting. Okay. Firstly, probably we most of the time we deal with CSV file, .csv files. CSV files are nothing but they're comma separated values. So these comma separated values files, um, we are like when you are going in some in Kaggle, when you go for any Kaggle or any test. So most of the times you encounter these .csv files. Okay, it's not that the CSV files. Of course, you can get Excel files, SQL files, um, so text files also. So but most of the times you have to encounter with the CSV files only. Okay, so we have something like we can read the CSV file with using the pandas dot read CSV. Pandas dot read CSV, and I am giving my path to my file. They're like home, my simply, then data sets, then my Boston housing dot CSV. Okay, so this is how we are reading the CSV file. If in case if I have to read my Excel file, then the syntax, then the command will be pandas dot read underscore Excel EXEL. If it is an SQL file, then the command will be dot read underscore SQL. Okay. Then if you want to save the CSV file to your like a computer, your PC, then the command will be very simple. Df dot whatever the data frame variable, df dot to CSV. Then we have to give the path. Where should the CS where we have to store the CSV file. Okay. So then we have some XLX files. XLX files are like the Excel files. Excel files. So the quite difference between CSV and Excel, like the CSVs are comma separated values, but this XLX are sometimes it is like they're mostly done in like a XLX, I think XLSV, XLS. So these are these are the main basic Excel files. So in these Excel files, if you're trying, you can manipulate the data using the Microsoft Excel. But in CSV files, you cannot do that. So there is some advantages and disadvantages. But but when it comes to pandas, using pandas, you can do anything. You can do anything with any file. There is no restrictions of using any files. You can import any type of file. Uh, like any type of file means that files are described that are predefined in our pandas. Okay. So then let us explore some data exploration technique. First one is dimensionality check. Okay. So the dimensionality check will be like so the dimensionality check will be like, yeah, okay. So here I'm having an exercise, e-commerce purchase. So okay, so this is an exercise. Let us go through this. The first thing is that I'm importing pandas. Import pandas as PD. Then after importing, see I'm having e-commerce purchase. You can see here I'm having the file in my the same folder. You can see here e-commerce purchase. Okay, this is CSV file. Okay, so I'm reading the CSV file pd.read CSV e-commerce purchase, and I'm simply running the file. Okay, then dot head will return me first five rows of my file. Okay, So the first five rows of my file, first five, 0, 1, 2, 3, 4. Okay, address, what are the address, lot, AM or PM. E-commerce purchase is e-commerce purchase is a data set. It is mainly discussed, tells about the customers purchasing in e-commerce, type of cards they are using, what are their mails, like their employment. So you have a number of things, a number of stuff inside this data set. Okay, then df.head is like, it will give my first five rows of my data frame. If I want to get the last five rows of my data set, then the code will be simple. See, df.tail. These are my last five rows. Okay, what? Okay, instead of, so now it is only showing me first five rows, but I want to know 10 rows, first 10 rows. Then the simple, okay, then the pass 10 argument in this df.head, in the brackets, 10, give 10 as its argument. Then we will get 10 by 10 rows. You can see it, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is how. Similarly, if you want to get the last 10 rows, then you can give it 10. So you will get the last 10 rows. Okay. So this is how the head file is used. And dimensionality check. Dimensionality check is, if I, so this is my data frame. Okay. So whatever the files we are reading using these pandas, they are default they are converted into data frames. Okay, whether you read a CSV file, Excel file, SQL file, Excel SV file, whatever the file might be, so each and every this file will be converted to as a data frame. Okay, so will be converted to as a data frame. So considering this data frame, we have to explore this data set, and we have to give insights about this data set. For example, if you are if you are placed as a data scientist or data analyst in any company, okay, then you will get the data set from your client. Okay, some clients is giving, let us take, you are placed at something called Deloitte company, which is an like a, it is like I think it's a consultancy companies, even Deloitte, KPMG or KPMG. Okay, these are consultancy companies. So some business persons, like some business executives, they will come to you, they will approach you, and they will say that, see, I am having this data set. Give me something insights about this data set, something hidden information in this data set, because data set contains some thousands or lakhs, some lakhs of values in that, lakhs of rows, or some lakhs of millions of values in that. But for them it is impossible to each and to, if you like it is like see, the old technique will be like, to you have to iterate to throughout the each and every row or each and every column, so it will take a lot of time. But this pandas, or using this modern techniques, it will make more easier. Okay, so how this approach can be is like that. The first one is, so dimensionality check. Okay, so the dimensionality means how many dimensions, like my data frame is how many dimension does it frame. So it is simple, like df dot shape. So it is saying that, so this data frame, like this CSV file is having 10,000 rows and 14 columns. Okay, so this is our first step. Df dot shape, it will gives you about the dimensionality. How many dimensions does your data frames have? Say data frame is basically, anytime it is a two-dimensional data, but it will give number of rows and number of columns. Okay, so that's the difference. Then type of data set. Type of data set is like simple type of df. It is me giving, it is returning me pandas dot core dot frame dot data frame. Means the df, whatever the df variable that I have declared here, it is of data frame type. Okay, it is of data frame type. Then the next comment would be like slicing or index. Okay, slicing or index. So now I am having my data frame. Now data frame is within my hand. Now I want to extract some of the values in between this data frame. Okay, let us now extract. For example, yeah, this 678 to 714. Okay, let us extract 678 to 714. See how we can do it. 678 is from fourth row. Sorry, from fifth row. Fifth, six, seven. Okay, 5, 6, 7. I will show you. So first thing is the df dot ilog. I am using ilog, index location. Okay, then the rows that I want to consider is that from 4, 5, 6, means I will give it like a fourth starting row, 4, It will be about 5, 6, then 7. The 7 will be my last one. Because why? The reason because only I want only these three values only 678 and 7169 and 714. I want to have only this values only. But I'm giving the seventh one. Instead of giving six, I'm giving seventh one because the reason is that in Python the last index value will not be considered. It will only consider the previous value of this one. Means the previous value of this one is six. So that's the reason we should have to give seven. Now I want to know the column number of this one. Okay, this column number might be 0, 1, 2, 3, 4, 5, 6, and 7. Okay, 7. See, the values are displayed here. Is it clear how we can use this indexing? You can extract the middle values of your data frame. Extract. See, but okay, instead of using this 7, let me take log. Okay, instead of using ilog, I will use log. It will give me error because ilog is basically it is an index location. Your index values must be in something integer format. But log is that here I have to give the index name. Means what is this index name? CCC security code. Before that, I should want to the columns name df.columns. df.columns. Okay, df.columns. So these are the columns, 14 columns that I'm having. So this is my dot column security code. See, that's the difference between log and ilog. Okay, is it clear? Hello?
Yes, sir.
Yeah, sure. Fine. Okay, so that's the difference between ilog and log. Okay, so log, when you are using the log, it is you must remember that you must use the index name. But when you are using ilog, so you must use the index number. So the indexes must be integers. You should not go for the string type. Okay, it might throw you an error. Probably it will throw you an error. Sometimes it might works, but most of the times it will throw you an error, type error. Okay. Then the next step will be slicing an index and identifying a unique elements. Okay. Let me take that. So in my data frame, I am having addresses, something like addresses. Let me go for uh, it is giving my unique job that is present in my data set. So these are actually there is no unique values. I think sometimes this is unique. Let me consider. Let me try to get the length of this. So type is I think so type is array type. So dot shape. Among this 10,000 data, we are having 623 unique jobs. Okay, if you want to know the names of the unique jobs, simple. Okay, you can run this df dot job dot unique. Okay, if you want to know how many unique elements we have, simple that is n unique. Okay, instead of you want to know the how many unique jobs, number of unique jobs, then the command would be df dot job dot n unique. So it will give me 623. Okay, so here I'm using df dot. Okay, you can use this type this format also. So it will also, so it can also be what. Okay, so there is no problem. Either you can use df dot job or df square brackets job. Okay, so this is in unique values. Then value extraction. Okay, so how values. So this is my data frame, but in this data frame, I want to know let me go for purchase price. Okay, so here I'm having one column name called purchase price. Okay, purchase price. I just want only this purchase values. Only see this 98.147.03 means I only my main motive, like my main objective is to obtain the purchase price values only. we should not consider the rest of the things, rest of the columns. So the approach would be like df uh, score, what is it, is purchase price. Okay, purchase price dot, if I'm only first of all I'm running only this code. Okay, it is written in a series. Okay, this is a series. See, in a series you are having indexes 0, 1, 2, 3, 4, and 10,000 indexes, and you are having the values. But this is series format. But I want only my values. Then the command would be dot values. So you will get an array of that value. So 98.14, 70.73, 0.95. You can see it here. So the every value is here. Okay, it is returning the values of certain column. Okay. Then future mean. Okay. Now I am now with my future values. Now my question is that question is that calculate. So your client is asking calculate the mean of purchase price. So there is some questions, there is some task as given to you. Calculate the mean of this purchase price. Then the command would be df.purchase.values. Then you can give dot mean. Okay, so it is giving me. So the mean of this purchase price column is 50.347302. Okay, so this is how we can do it. If you want to know the standard deviation, then it would be STD. This is the standard deviation, the spreadness of your purchase price. Mean is the central value. Standard deviation is the spreadness of your data. Similarly, if you want to go for let me give the axis. Is it necessary to give axis? Yes. Don't go for mode. Mode is for actually data frame only. So again, okay, instead of without using the values, we can directly extract the mean like this also. Now it is also giving me a mean. You can extract the standard deviation also. If you can extract the mode. Okay. Mode means the data value which has been repeated most number of times. Mode. Okay. So this is how some statistical. So these are some statistical techniques, basic statistical techniques. Okay. These are some basic stat techniques. Okay. Future mean, even if you want to go for median also, we have df dot median. Okay, similarly for mode, just I have shown you recently. Okay, let us go for something visualization. Okay, so is it clear, these techniques, dimensionality checking, type of data set, slicing, identifying unique elements, is it clear for you? Hello, any response?
Yes, sir.
Yeah, okay, fine. Now let us move to some visualization. Okay, visualization is nothing but it is something you are like to, because see, sometimes data is in anytime it is in a numerical format. Okay, so seeing any numerical data, you cannot come to any conclusion. Okay, you cannot come to conclusion because we cannot just only we can see the numbers, but we cannot see the truth behind that numbers. What is the main intention of that numbers? So for this type of problems, we have some type of visualization techniques. Okay, the visualization can be done using Matplotlib, Seaborn. Okay, they are the most powerful visualization techniques in Python. Okay, this Matplotlib or whatever you are seeing here, the import Matplotlib. Okay, this Matplotlib is basically they are taken from Matlab. Okay, have you ever familiar about Matlab? Matlab is also not a programming language, so it was used earlier time for mathematical operations. Matlab. Okay, I think it is basically for ECE people, for something EEE people you will encounter it. Matlab. Okay, Matlab is also programming value. So this matplotlib has been taken from this Matlab only. Seaborn is something advanced of Matplotlib. Okay, In Matplotlib, the cannot perform all of the operations, but Seaborn is more proficient in like in for n number of techniques. It can give you best visualization comparing to a Matplotlib Seaborn. Okay, so correlation for what is this heat map? We are having heat map. Heat map is some type of visualization technique. So heat map basically gives you the correlation. Basically, correlation means correlation is nothing but I will show you. See here I'm having 14 features means 14 columns. See here I'm having addresses. Okay, let us don't not let us not consider this string type of features means address is my string type. Okay, let us don't consider it. This loaders also is a string type. AM or PM is a string type. Browser info string type. These are string type. Okay, this credit card. Let us take credit card and something like a CSV security code. Of course, there is a not good relationship between this credit card and CSV security code. Okay, but there might be when you try to when you try to explore this credit card and CSV security code linearly. Linearly means that is there any relationship like increasing in credit card number there is an increasing security code. Okay, this could be not the good one because the statement is what I'm making is not a justified one because anytime credit card doesn't depend upon security codes. Sometimes it's a mismatch. Okay, but for better explanation, I'm saying that let us consider I'm having an A variable and B variable. Okay, to explain the relationship between A and B means how the relationship between A and B there. Either it is a positive relation or negative relation. Means what is positive relation means that increasing one unit of increasing of one unit in my A future will be lead. It is leading. It is motivating my B to increase in one unit. So we call this is positive relation. Means if I'm increasing A unit, if I'm increasing my credit card future, then there is an increasing in my security code. Okay, this is called positive. If I'm decreasing this credit card, then there is a decrease in security code. This is we call negative relationship. So this positive and negative relationship is given by correlation. So correlation we have different type of Spearman correlation. I think Spearman's correlation. We have different type of correlation techniques, and there is a formula to how to calculate the correlation between two features or two variables. Okay, so that is the correlation. So correlation is that basically. So if you go for visualize, so this is the heat map. So heat map. Okay, this is the Boston data. I think it is the Boston housing data. Boston. In that Boston housing data, you are having columns like mid-wall, Stat B, PT ratio, taxes, radius, distance, age, Knox, Chas, Indus, zone, crime rate. Okay, you are having this type of features. So it is giving me the relationship between each and every features means zero point 0.1. If the correlation, if the value is zero point 0.1 means the two variables is having good correlation. If the variables is zero, if the correlation between two variables is zero, so there is no relationship between those type of variables. Similarly, for if the relation is something minus zero point 0.6 means the relationship is in minus 0 minus 1 minus 1 means so there is a negative correlation means there is negative relation between both the variables. So in this here let us consider this heat map. um, let's go for this value. Okay, this blue color. Okay, so it is showing me in this feature is having negative correlation with distance form. Okay, so this distance feature is having negative correlation with some Knox as well as Indus because it is in blue color, dark blue color indicates that the value of the correlation is minus 1. Dark red indicates that the relation between two variables is plus 1. Plus 1 is positive correlation, minus 1 is negative correlation. Okay, so this is some importing data, dimensionality check. Okay, fine. Okay, this is data mixing. Okay, no need of data wrangling. So previously no, before this we have done with data manipulation. Okay, now we are dealing with data wrangling. Data wrangling is nothing but see in our data frames there is a chances of your data points are missing some points. Okay, there might be some noises means outliers there can be present of inconsistent data. Okay, to develop an accurate model, so there is you must perform some data wrangling techniques upon your data. Okay, and prevent data leakage. Okay, so these are the main common problems that we uh, encounter in our data. Okay, missing values means Something missing values can be, let us consider, let us see this. See here I am having a data frame. See, in this data frame, there is certain cells where there is no values filled. Okay, what is the reason might be that during the customer or during the so it is a passenger ticket format. So during the check-in, the customer has doesn't enter the age value or something cabin value, okay, or he doesn't enter anything. So that's the reason. So these columns are left blank. Sorry, these cells are left blank. Okay, this is leading to non values. Means there is we are not sure about the non we are not sure about the value. So data frame will frame it as a non value. Similarly, it is a cell value with it is a blank cell, then it is framed as a non value. So this is what is non values. Means there is something missing in your data. So this missing data is framed as non values. Okay. So how to detect any missing values in our data frames? Okay, the simple. So here I'm having data frames. Let me go for any random one, random column I'm taking. Let me go for job. Okay. I want to know whether in my job column is there any null value present in df.job dot is na. Is na means is there any null value? The false. It is giving me something binary format. Then I want to know the integer value. Then I will do dot sum. So there is zero non values. Means your job column is having zero non values. Okay. So you can go with like this also. Dot any method also. It will give you false. So it is false indicates that there is no non value in your job column. Okay. Which is non values. Let us go for something. So how to okay. Okay, so the first thing is that we have find out there is something missing values in our data frame. Now, now there is something you should do. You as a data scientist or something as an engineering, you should do something techniques. You should pre-process these cells. Means you should fill up these cells with some values. Okay, you should fill up something these cells also with some values. Okay, because why? Because the reason is that because this is a data set I'm having. When you are training a data set to your model, there should not be any non values like in our like machine learning models, like when you go for logistic regression, linear regression, whatever that model might be. So the time you are training, at the time you are training your data set to the model, you must make sure that there is no null values present in your data set. There is no string value. The main thumb rule is that there should be only integer values. Either it can be float, double value, long value, okay, whatever the byte format, whatever the format might be. But the thing is that the whole data should be in integer format and there should not be any string value. Okay, but the question can raises in your mind. See, in our sex column, we are having string values. Okay, how we can change them? Similarly, in ticket column, we are having string values. How to change them into integer types? So, okay, for this type of problems, we are having encoding method, one hot encoding, like one hot encoding method we can use, then we can encode. So what is this encoding method does is that so it will frame this male as 0, female as 1. Okay, so the encoding method does it works is like that. It will give 0, it will give male value as 0, female value as 1. So this is so how the string value, then the string values are converted to integers. Okay, so this is we call as encoding. So what is the rule? That there should not be any non value. So we must fill something. We must fill something in this non value. Okay. Let us. Is it? My question is that can I fill any random value in this cell? Any random value? Is it good? Can anyone?
No, sir.
Yeah, it's no. Because if you're giving something random value or something any random value to data frame, it might mismatch your model. Your model doesn't perform well in classification or in regression problems. Because these data anytime naturally occurring data, they follow some certain patterns. There is some hidden patterns in the data. Okay, if you are trying to change the patterns in the data, it might affect your model. Okay, So anytime, don't go for any random value filling. So we have some techniques to fill these values. Okay. So the values is that from sklearn. Sklearn is a strong library. So I will show you sklearn. So sklearn is a module. sklearn is like it's an API. It is basically an API. So where you can have different type of algorithms. So let me go for classification. In classification, I'm having linear models, some linear models like a logistic regression and linear regression. So we are having n type of models. Okay, we are having polynomial regression, LDA, LDA, linear discriminant analysis. We are having something different type of models. Supported vector machines. This is a machine learning model. SGD, stochastic gradient descent. It is an optimization technique. You can use it for classification. K nearest neighbors, Gaussian process. Okay, these are all the predefined machine learning models. Okay, so in this we are having something like sklearn.preprocessing. It's down here. Yeah, pre-processing. Sklearn.preprocessing. Here I'm having imputation of missing value. See, imputation of missing value means imputation of missing value is that from sklearn.preprocessing import imputer. After importing the imputer, I'm calling this importer object missing values is equal to np.none. So what I'm saying is that if you are trying to find any np.none values in my data frame, fill those cell with the mean of my column. Okay. So instead, let us take. So here in the age cell, I am having this cell as blank, none value. So what this imputer does is that it will calculate the mean of this age column, and whatever the age mean that we are getting, so that value is filled up in this cell. Okay, whatever the value, the mean value we are getting from this 22 plus 38 plus 26 plus 35 plus 35 divided by 5. So whatever the value we are getting, so that value is filled up here. Okay, similarly for cabin can be sometime different. Okay, because cabin some values are none, so we will give 0 0 only. Okay, because there is no nothing method we have to deal with the string type of data. If you are having integer, we can go with mean, median, maximum value, minimum value. You can fill with any value that depend upon you. Okay, so this is the one technique. Value treatment. Okay, and not only sklearn pre-processing, my suggestion is that if instead of using sklearn or pre-processing, I will show you another library, which is Future Engine. It is the best, one of the best pre-processing library, because here you can see it that missing data imputation. If you go for missing data imputation, here we have different type of modules. See, mean median imputer, categorical imputer, random sample imputer, adding missing imputer, dropping missing in data. So if you go for mean median imputer, you will have the code also. So this is the code. So instead, so in here only we just try to fill the mean value, but this module will try to fill the mean median imputer. Okay, it can fill the median also. It can fill median value also. So the thing is that go for this future engine library. Okay, future engine library. When you are go for any data pre-processing technique, my suggestion would be go for this future engine library. You can have different type of imputers. Okay, arbitrary number imputer. Okay, arbitrary number imputer is nothing but, see, you can give something, use a different value. I am giving something like number 99. So if there any none value is identified by this model, then it will fill the none value with 99. Okay, this is how you can fill. Similarly, we have entail imputer, categorical imputer, different type of imputers. Okay, you can explore them. You can explore these libraries. Outliers is nothing but, see, most of the data is following certain patterns. It is following certain trends. Trends means something increasing, decreasing, increasing, decreasing, increasing, decreasing, increasing. But you can see there is a certain point which is beyond, like which is something, it is going beyond this range, beyond this range. So we call them as outliers. Yes, outliers can affect your model building. Outliers can affect your model building. So there is a cause. There is a cause and there is a work to do that. You must detect the outliers in your data before training your data to a model. Okay, you must detect the outliers and you must remove those outliers. Okay, there is a you must remove those outliers, and in the place of outliers you can fill the cell with the mean value of the data. Okay, so how you can dealing with basically these outliers can be visualized using box Cox plot. We call them as box Cox plot. So this is the box Cox plot. Box Cox plot. In this box Cox plot, if you're going assignment is in one my column, I am giving assignment as to this library. Then I am getting see these dot points. Most we can frame it as like see this is a 25% quartile percentile. Are you people familiar about this percentile of data? It is saying that 25% of my 25 percentile of my data, and this is showing my 50 percentile of my data, 75 percentile of my data, and this is my 100 percentile of my data. It is showing something distribution of your data. Distribution means most of the data is beyond your 50 percentile of the data. Okay, something box Cox plot, we basically it gives you intuition of, okay, that's the main intuition of the box Cox plot. So these dot points are basically the outliers. Means the we can see that, so the outliers is greater than 60, means in my assignment futures, if you are encountering any value greater than 60, so we must consider them as an outlier, because most of the values are less than 60. So most of the values in my assignment are greater than 60, but the values which are less than 60 are my outliers. So this would be the approach to detect the outliers in your data, because outliers will misuse it will try to confuse your model while performing doing classification or regression, or like doing clustering or any type of method. So yes, we can deal with the outliers, nothing but, so we are giving something that value is greater than 60. Then we are filling those values with 60 with something values. So this is head. I think you people were not head method, tail method, values method, group by method. I will tell you what is group by method. Concatenation is nothing but merging of two data frames. Okay, like concatenating two data frames. Okay, group by method. Let us go for this group by method. Let me go for the CC provider, means the credit card provider. In my data set, I'm having credit card provider. Let me go for this future CC provider. Want to know dot unique. So these are my unique credit card provider. Then I want to get only the customer names who are purchasing using Mastercard. Okay, the task is that display display the customer names who are using Mastercard. Okay, so this is the question we are having. So how can we do it? It's nothing but df dot group by that group by I am giving cc. Okay, we can do like this. Let me go for df of square brackets df of cc provider df of cc provider is equal to master card giving me data frame. Now I want to know only the customer names. Then again brackets. What is the customer names column? Company. Company. What is the customer name column? Okay, let us go for email. Means my question is that actually there is no customer name column here. We're only having the customer ID, I think. Yeah. But let us go for email. The email IDs which are using MasterCard. Then I will print your email. We are getting the email. So these are the emails they are using the MasterCard. Okay, this could be the technique. Okay, means this is called inner indexing. See, in our data frame, in my data frame, again I am indexing. Again I'm indexing innerly. We call this inner indexing. Okay, using this technique you can find out anything. So this is some data pre-processing techniques. Okay, so can I take a 10 minutes extra today because I want to give you something standardization and normalization of your data. That's the main important point because okay, so what is standardization and what is normalization data? See, I'm having my future one. Let this be future one. Okay, let this be future two. Okay. Okay, let this future one be weights of students. Weights of students. Let this future be weights. Future one. Let this future two be something like height of your students. So these weights can be basically we go for kilograms. Okay, the values can be 50. Okay, 50, 60, 40, sometimes 120, might sometimes 80. Okay, but this height columns is something like we go for inches. Okay, feet and inches, 5.5. Okay, similarly we are having something like 6.0. Okay, 7 point let us go for 7.14. Great Kali. 1.49. Go for lattice and 3.2. 3.2. Okay, see, the reason is that scaling matters a lot. Okay, because the weights are measured in kgs, kilograms, and your height are measured in either centimeters or meters or in like inches. Okay, or in feet. Okay, so there is a difference between the scalings because scaling is nothing but the measurements you are using, the dimension or the for weights. Anytime for weights we go for kgs, kilograms, or sometimes pounds. But for height, we will go with centimeters, meters, and inches and feet. The reason is that see, if I'm training like something like my model is that let me consider I'm want to build a machine learning model. Considering these two features, it must give me the body mass index, BMI of the student. I think you people are familiar about BMI, body mass index. Okay. So the task is that considering these two features, my machine learning model, my machine learning model must give me the body mass index of student. Okay, okay, you are ready, the data is in your hand, you are going on, you are like the, you know, the some machine learning models. Okay, you know the linear regression. Okay, you train this data, you train these two features to your linear regression model. Okay, it will try to predict, but the training accuracy will, you will get the training accuracy about 95, 95% accuracy. That's a good. In testing accuracy, testing or validation accuracy. Okay, in testing accuracy, the accuracy might be something like 60, 70. Okay, so we call this as an overfit model. We call them as an overfit model. Overfit is nothing but, see, data is performing well on my training data. Sorry, well on my data is performing. Sorry, model is performing well on my training data, but my model is failing on my testing data. Okay, machine learning models, there is something justification you have to give. There is something justification you have to give for your clients, that is my machine learning model is performing well or not performing well. Okay, so for this purpose we have, there's a number of techniques like F1 score, confusion matrices, precision score, uh, recall score. Okay, we will deal in our coming classes, we will deal, I will tell you what are these techniques. Okay, so my training accuracy is 95% and testing accuracy is 60 to 70%. So we say that our model is overfitted. Model is overfitting means your model is performing well on the training data, but it is failing on testing data. Means there should not be this much difference. Okay, we are having two types of, it is basically this fitting method, fitting categorized into three types. The one is well fitted. Okay, well fitted. The second one is overfitted. Okay, the third one is underfit. Okay, well fit means my accuracy could be something like 90, 88, means training accuracy 90, testing accuracy 88, or 75 or 70. So this could be my model, well fitted model, means there is no underfit and there is no overfit. Overfit could be like my training accuracy is 95. Okay, my testing accuracy is 75. There is a lot of difference between this. Similarly, something like 75 and 45 means 75 accuracy on my training data, 45% accuracy on my testing data. Underfit is like that. It won't perform good on training and it won't perform good on testing data. Okay, my training accuracy could be something like 40. Similarly, my testing also will be 40, 20, or 20. Okay, so these are the categorization of your fitting of your model. So at any time your model should be well fitted. Okay, you can encounter overfit or underfit during the process, but you must overcome. You must have to overcome this type of process. So to overcome this underfitting, we must have something like standardizing the data. We must have standardized the data, either standardize or normalize. Okay, first approach could be that. So first thing is that, okay, you like you are building a machine learning model. Let us assume that, so you people build a machine learning model, but the model is, it is an overfitted model, means the accuracy is 95%, but the testing accuracy is 60%. So you have encountered, there is, so you have observed that there is an overfit in your model. So the first step you should consider is that the scaling is different in your model, in your data, because the weights are measured in kgs, the height is measured in feet. See, you can see here the difference. See, see, you can see here for student one, the weight is 50, the height is something like 5.6, 5.5. Okay, here 60 and 6.0, 47, 7.14, means here the values are in 10 units. Here the values are in 1 unit. Can you see the difference? See, here the values are in 10 hundreds units. Okay, this 55 into 10 means 5 into 10. I'm writing is a 5 into 10. Okay, means it is basically, you can describe it is in the 10 units, 16 to 10, 40 into 4 into 10, 120 into, sorry, 12 into 10, or 12 into 10, or something, you can go 8 into 10. Okay, these values are in 10 units, but these values are in 1 units. means 5.5 into 1, something 6.0 into 1. So this we call, see here the values are varied in tens, means this value is varying in 10 units, some in 10 units. Similarly, this value is also varying in 10 units. But here my values are varying in only 1 unit. See, you can see the difference. What is the difference between these two? The variance of between these two values are different. So the main reason is that scaling means for my future one, I am scaling it as a weight. For future two, I am giving it as a height. Means weights are measured in kilograms and my heights is measured in feet. So for this reason, so we must standardize the data. Standardization is nothing but standardization goes like this. Okay. Okay. Standardization formula is like that. STD x minus mean of your future divided by standard deviation of your future. Okay, standardization is nothing but means my 50 value for my future one, how this value can be replaced is that 50 minus, what is the mean value of this one, 50 plus 60 plus 40 120 80. You go for 50 plus 60 plus 40 plus 120 plus 80. People, are you getting the things? Hello.
Yes, sir.
So the mean value is 70. 50 minus 70 divided by the standard deviation. Let us take the standard deviation something. Standard deviation, let it be something. 70 means it will be approximately 20, I think. Okay. So 50, let it be 50 or something, 25, 25. Okay. 50 minus 70, it is minus 20. Minus 20 divided by 25. Okay. Minus 20 divided by 25. So you will get a value in between 0 to 1. Okay. So this value is replaced by something 0.5. Similarly, the same formula is applied to the second value. Again, this value is replaced between something decimal value 0.4. Let us consider. Similarly, this value something like be um, 0.6. Similarly, this value be 1. Okay, this value be 0. So you can see that after applying the standard deviation, most of the values are in between 0 to 1. Okay, means it is reducing the scale, it is reducing the values. Okay, there is no, you are not losing your information. Okay, so you might get something question in your mind that, sir, we are converting this our scales to some other 50 to 0.5 decimal format from 0 to value. Is there any chance of losing the information? Is that there is no chance of losing information. You are only converting, you are only decreasing the scaling values to perform model accurately, to get a good accuracy in your model. Just there is something scaling difference between in your future columns. Okay, so to overcome this scaling difference in your future columns, we must standardize or normalize. Okay, so my values will be between 0 to 1. Similarly, the same formula is applied upon this feature. Okay, here the mean might be different because here I am considered the mean of weights. Here you should consider the mean of heights and standard deviation of heights. So this value can be 1. This value can be 0.4. Example, I'm taking roughly something 0.4. Again, this value can be 0.3. Okay, again, this value can be 0.0. Okay, so here now you can see that, see this values and this values. Okay, is there now there is there any scaling difference between them? After I'm applying the standard deviation, is there any scaling difference between them?
No, sir.
No,
No,
sir.
because each and every values is, they are decreased, they are degraded to in 0 to 1, in between 0 to 1. Okay, now you can model can perform well. Now you can overcome the overfit. Okay, so of course there is it is not 100% sure that you can overcome overfit. There is okay, you can increase that. See, that's 95 to 95. See, that's 95 to 75 can change after applying the standard deviation. It can go for 95 to 80. So means your model is performing 95% on training data and 80% on testing data. Still there is some overfit. Okay, still there is some overfit. It is about 15%. 15% of difference between this one. Yes, we can overcome this something using some regularizers. Okay, regularizers. We have L1, L2, L1, L2 regularizers. So in our classification approach, I will say what is this regularizer. It is something that penalty upon weights. Okay. So this is standardization. Similarly, we have normalization. Normalization is nothing but x. Here in standardization, we have taken x minus mean divided by standard deviation. Here, x minus, I think x minimum or x max. I think x minimum, x minus x min divided by x max by x min. So this would be the formula. I think it is x max, x max. Yeah. So for normalization, the same formula. The approach is the main intuition is same, but the formula is different. Here you are using x minus mean divided by standard deviation. Here you are using x minus x maximum but divided by x max minus x min. Okay, this is the difference between standardization and normalization. And you are having the TAR technique also, max min scalar. Okay, but that is not most widely used, but this is the most widely used technique. Okay, so this is the standardization. Okay, you are completed with your pre-processing techniques. Data pre-processing. Uh, I think actually it's 10 minutes late. Okay, is it clear? Hello?
Yes, sir.
Yeah, okay. So I will be sharing this exercise with you. It will be your task. It's not mandatory that you should do each and every question. It is up to you how much you are capable of. You can do it. So if you are interested, you can browse something, because during this only 1 hour session, I haven't covered most of the techniques. We are having pivot table, group by method. Similarly, we are having something like standardization, imputer, filling the null values. I haven't shown any demos. Okay, but still you are having some laptops in your. You can browse it. Okay, the question will be, you can just you can copy this question and you can paste in your browser. You will get something hidden. You will get something like a hint. You will get something hint in your browser. Okay, based upon the hint, so try to solve this type of questions. Okay, I will share the CSV file and this Jupyter file. Okay, it is your task today.
Sir,
Yeah,
can you
okay.
send that PPT also, sir?
Yeah, sure. I will send the PPT also.
Yesterday you have sent it, sir, but removed very quickly.
Yeah, I remember, because there is something different. Copyrights actually. Okay.
Okay, sir.
So today I will send you the CD PPT and this data frame file. Okay. See, sorry, this Jupyter file. Okay. So do perform well. Actually, see, whatever the techniques I am giving, no, so these are the data analysis techniques. Okay. Whatever the questions that I'm giving here, these are the main task of the data analyst or data scientist. Like before you are building any machine learning model, you should perform some exploratory data analysis. Make a note of it. See, this all these are EDA. I'm writing here. These are EDA techniques. We call it as exploratory data analysis. Okay. These are the basic exploratory data analysis. Again, we are having hypothesis testing, kurtosis, skewness. There are a lot of hypo distributions when we talk about EDA. But these are some basics. These are some basics data analysis techniques. Like if you're going for any interview as a data analyst or data scientist, for damn sure you will get this type of questions. The company can give you any random data set and they will give you these questions like this. Perform these commands upon them. Okay. So this might be very helpful for you. If you're having any doubt regarding any question, ping me in WhatsApp. I will respond for you. Okay. Fine, students. You can leave. You can leave right now.